NASA's Discovery program has funded some of its most famous missions of the last couple of decades, including projects like the Kepler telescope and the Dawn spacecraft that have revolutionized our understanding of both our solar system and the universe in general. And back in October of 2015, we told you a bit about the 5 finalists for Discovery's next generation of missions. Those 5 teams have spent the last year or so beefing up their proposals, and finally, NASA has made a decision. We're headed to some asteroids. The first mission is called Lucy, and it's scheduled to launch in 2021 and do flybys of 6 different asteroids by 2033. One of those asteroids is in the main asteroid belt between Mars and Jupiter, but most of Lucy's targets are trapped in patches along Jupiter's orbit, where Jupiter's gravity sort of balances out the sun's. Astronomers think some of these asteroids formed near Jupiter and Saturn, and others started farther out, but got caught by Jupiter's gravity when they got too close. So investigating a whole bunch of them gives us a way of studying what was going on throughout the early solar system. Some of Lucy's main tools are improved versions of cameras from New Horizons that studied Pluto, which it'll use to photograph and map the surfaces of all of those asteroids. The second new mission, set to launch in 2023, is called Psyche, after the asteroid it's scheduled to start orbiting in 2030. The asteroid's full name is 16 Psyche, and it's one of the biggest asteroids in the entire asteroid belt. But that's not the only reason NASA's so interested in it. Every asteroid we've ever visited was made of rocks and minerals and ice. But 16 Psyche is the only big asteroid we've ever seen that's made of metals, like iron and nickel, the stuff that's deep down in Earth's core. And astronomers aren't quite sure why all that metal ended up in one place. It's possible that 16 Psyche is the core of an ancient would-be planet that either never finished forming or somehow got ripped apart billions of years ago. 2 of the Psyche's orbiter's goals are to map the asteroid's magnetic and gravitational fields, which will help us learn where and how it formed. We'll also find out whether it's really metal all the way down, or if there's more to 16 Psyche than meets the eye. Closer to home, a study published in the journal Nature Geoscience has resurrected an idea explaining the formation of our moon. Most astronomers subscribe to the giant impact hypothesis, where a Mars-sized protoplanet called Theia crashed into the Earth billions of years ago, and the moon formed out of debris from that collision. But there have always been some lingering issues with the giant impact hypothesis. For one thing, whatever happened to Theia? Theia's remains should make up about 70% of the moon, but moon rocks brought back by the Apollo astronauts were very similar to Earth rocks. So similar that they seemed like they couldn't have come from anywhere but Earth. It's possible that Earth and Theia just happened to be made out of identical rocks. Researchers recently found that there's about a 30% chance that the early Earth could have been hit by something so chemically similar to it. But another possibility is that Earth was never hit by a giant impactor like Theia at all. So for this new study, a group of planetary scientists simulated what the moon would look like if material came from a bunch of medium-sized things hitting Earth instead of one big one. The idea's been around since the 80s, but they've given it new life by simulating almost 1,000 early solar systems. And they showed that it would only take about 20 impacts to form the moon as we know it today. Considering everything that was flying around the early solar system, 20 good whacks definitely isn't out of the question. And with so many different objects contributing to the moon, it would make sense that none of these rocks would stand out from the rest. So the moon should look a lot more like the Earth than anything else, because the Earth makes up more of it than anything else. Which is exactly what we've seen. Don't expect astronomers to rush out and change their textbooks though. The giant impact hypothesis still does a pretty good job of explaining the moon's formation. It's just not the only possibility. So it'll still take a lot more research to find out exactly how we got our moon. Thanks for watching this episode of SciShow Space News. If you want more space news, make sure you go to youtube.com/SciShowSpace and subscribe. And if you're already subscribed and just want to hang out and talk about space and science in general, in person, the SciShow team will be at NerdCon Nerdfighteria in Boston, February 25th and 26th. You can go to nerdconnerdfighteria.com to learn more. And finally, China is going to the moon. Since 2007, the China National Space Administration has been launching moon missions in the Chang'e program named after the Chinese moon goddess. And Chang'e